Okay. Yeah, so let's get started now. Today we'll just be continuing the demo that we started last week in terms of remaking our database, remaking our to-do list app again, but this time using abstractions instead of raw SQL like we did with in the past couple of lectures and stuff like that. So can everybody just pull up their db.py file and app.py file? I'll give like a minute or so to do that. Okay, so I guess you can keep pulling it up. I'm just gonna quickly go over what we did last time. So last time we basically implemented the basic setup in our database file. We implemented the task class and we implemented the subtask class here. Remember that now with an ORM, an object relational mapper, SQL Alchemy helping us, we can implement these as like objects in our object-oriented language of like Python. And then we just need to specify that these are essentially models. And again, models are just like a blueprint of a way that we would build an entry in this database. So just as a brief review, note how the class task has fields ID, description, and done, just like how an entry in our database to the tasks table would have a column ID, description, and done. Similarly, in Subtask, we see that when you instantiate a Subtask object, it has ID, description, done, and the task ID it's associated with, which we specify here that is a foreign key. So similarly, if we were using just like raw SQL again, if we actually looked into the database, the columns that would exist are ID, description, done, and a task ID that's a foreign key that references an ID in the tasks table. Okay, does this make sense to everyone? Okay, and then one last thing from last time that I noticed was a little bit off. I forgot a comma here, so just make sure to put the serialize function returns a dictionary. So just make sure that it's properly syntactically annotated as if it's a dictionary. Okay, so yeah. So now today we'll be starting off with the endpoint to get all of the tasks. Okay, so to get all of the tasks, there's a couple, or like what we're traditionally familiar with is just like calling an endpoint or calling a function in our database file and having it get all the tasks for us. Back in our third demo, we just had the database file kind of execute a SQL command. But this time, we don't actually have to execute any SQL commands because SQL Alchemy knows that it's supposed to mimic SQL, and it has a function for us that will retrieve everything in the database that it's also kind of prepping up for us. So let's instantiate an empty list for tasks. And then we'll loop through this thing called task.query.all. So I'll just type it out really quickly. So what is task.query.all? That's essentially the get everything function that SQL Alchemy has kind of pre-built into it. Task here references the the task object from the database file. And then because this is instantiated with db.model, we can call .query.all, which are SQL Alchemy functions, to get all of the tasks in the database. Just a quick note, make sure in the import section, you've also imported from db import the class task and from db import the class subtask so that we can actually call these functions on the tasks and the subtasks. Okay, so once we loop through for task and task.query.all, we can append to our empty list. Remember that the serialize function essentially takes that task Python object and returns a more digestible dictionary for us to use. So we append that into our empty list, and then we throw that into our success response. So dictionary with a key named tasks, and then tasks. Okay. So with this, let's go into Postman and kind of test what's popping. So in demo 4, instantiate a new get request for get all tasks. We have to run the app first. So now that the app is running, let's go into Postman and hit this endpoint. And we'll see that the tasks is currently an empty list, which makes sense for us because we haven't added any tasks into our database yet. Okay, so one thing to note here is that this is like a lot of like lines of code for something that we're doing that's like pretty simple, right? Like we can actually simplify all of this code into an easier way to just like, or it does the exact same thing, but we just don't have to write it in this many lines of code. So instead, what else we can do? So if I just like comment all of this out for now, we can also just create a table such that we have tasks or task.serialize for task in task.query.all, and then return this this list. So this Python syntax essentially allows us to just call this particular function on every item in this like iterable list that task.query.all returns. If we run this again in Postman, oh, wait. Oh, okay, it's supposed to be a, you can still throw this into the success response, but tasks. Run this in Postman, you still see that we get the same thing. Just for those who might need a quick, like, just like a more, I guess like descriptive way of what this is doing. Let's just like do something pretty quick in this terminal. So let's just say that we create a function. Okay, so essentially, I just want to demonstrate that like this Python syntax essentially applies that first function you call to everything in the like second part of the function that you can iterate through. So for example, let's say we have a list that's just like 1, 2, 3. Let's print out add 1x for x in LST. So what do we expect this to print out? Yeah, 2, 3, 4. So yeah, it prints out 2, 3, 4. So this is just like a quick-handed waste of like quick-handed syntax such that you don't have to write so much code. So it helps with kind of like readability and stuff like that. Okay. Does anybody have any questions on get tasks? Okay. If not, we'll go into create task. And again, just as a heads up, we have some TAs here. So if you have any like questions with like syntactical errors in your code or just anything that isn't working as you're following along, feel free to raise your hands and we can have one of them help you as well. Okay. So let's go on to create task. So for create task, it's going to be a post request again, right? Just like in everything that we've seen so far. And with a post request, what happens is that you have some kind of request body that comes in from the front end, right? Which makes sense because you need some particular like items in your task to actually create the task that we're looking to create. So we'll do body equals JSON.loads request.data, which is exactly like what we've been doing before. But this time, instead of executing some kind of like SQL command to add this new task into our database, we're instead going to instantiate an instance of the object task. Why are we doing that again? Because remember, now we're representing instances in our database as objects instead of as like, a particular row or something like that. So let's say new task is equal to task, where the description is equal to body.get description. So remember, the JSON.loads will turn in the JSON that the front end passes to us into a dictionary, which is an easy way to access information for us on the back end here. So the description for this new task is body.get description, and the done for this new task, just to like indicate whether or not it's completed, is body.get done. Now we have to actually, add this into our database, right? Like this is an entry in our database, but we still need something. We still need to call some functions to like, actually do the adding and also kind of like save our database's new state. So SQL Alchemy, again, will help us take care of this with some pre-built-in functions. So we just do db.session.add new task, and then db.session.commit, which is something you've also should be pretty familiar with from the previous couple of demos. And just a quick explanation as to why we have to kind of like separate the actions of adding and committing. Like a bigger, just like the biggest reason why this is going to be pretty helpful for us is just because like if we want to add multiple things into our database, you know, I guess like at the same time, or not at the same time, but like kind of like consecutively, it would make sense to do all the adding first before saving, right? Because saving takes a lot of resources. So if we continuously save after every single time we add, that's going to like, I guess like be very taxing on our system. But rather if we do all of the adding first and then I'll do all of the committing end, again, it kind of like gives us better runtime, which is the reason why we kind of separate out these two actions. Yeah, and then finally, we would just return the success response again for this new task. And remember, we want to serialize it so that it's in an easily readable dictionary format that can be turned into a JSON, and then give the success code 201. So remember from last time, the success response essentially allows us to default to 200 or provide a code in there to change it up if we want to. And this time we do want to change it up because it's a post request, and a successful post request has a 201 code as opposed to a 200 code. Does anybody have any questions here? Yeah.
What are we committing to if all we're doing is instantiating an instance of the task object? If there's no actual database.
Yeah, so there is an actual like database. It's just essentially like each entry, and we're no longer directly working with the rows in the database, but we're representing each row in the database as an object to kind of manipulate here in our app.py file. So once we create the object, we still need to kind of put it into the database as a row. Like SQL Alchemy recognizes like, oh, you know, this new object was created, but now I need to actually like translate from object to entry in database, which is what this add is essentially doing. And the commit will just like save the whole thing.
Thanks.
Yeah, no problem. Any other questions? Okay, so yeah, let's go into Postman and test this out. So we have create a new task. Okay, I think my address is different, so let me update this address part. Okay. So let's say the I don't know, the task might be like get better at Smash. Okay. Name request is not defined. Can I not import request?
I didn't go out. Yeah, I'll see you back there, okay, buddy?
Hmm? Please ensure. Okay, thank you, Maxwell. But yes, that's happening for you. Make sure to import requests because it's something that you need to, or like it needs to like know about in order to actually process the requests that are coming in. Okay, so yeah, here we can like create a new task. And if we get all tasks again, we see that it shows up in our database and comes back out too. Any questions? Okay, so yeah, let's move on to get task, like a specific task by the task ID. Okay, so here remember in the past, what we kind of wanted to do was we wanted to, query the whole database and find the first tasks that like match the task ID that we provide to it, right? So we're going to be doing something similar, but instead of, again, entering a raw SQL command, SQL Alchemy has something that kind of does it for us. So we'll, name the variable task, which is like the task that we're looking for, is task.query.filter by, which essentially, as the name implies, will kind of filter all of the entries in our database. ID equals task ID dot first. So essentially what this dot first part does is that it'll just pick the first one, that comes up, which is like in most cases going to be the one that we're going to like want to identify, right? And actually it should be in all cases too, because we've like isolated this ID to be unique, right? Given that it's a primary key. So the first one that comes up should definitely be the first one. But just in case, there are more than one that comes up for some reason, you get the first one. Okay. And then just like before, we also need to check whether this task is actually like a valid task. So if task is none, then we would return a failure response, right? So now we can specify like an error message to go with it. So our error message here would be task not found. The code defaults to 404, and since 404 is not found, we should be good to go. Okay. Otherwise, we would return a success response. And then we would want to serialize the task again, because just to make it a more easily processable dictionary, and can turn it back into a JSON. Okay. So yeah, let's try this. Get a task by ID. So the first task in the database should be, get better at Smash. Oh, I don't think my app is running. Wait, what? Oh, it's the address is wrong. Okay, so the first one should be get better at Smash, and that returns that. Any questions here? Okay, if not, let's move on to update task. Okay, so for update task, again, since it's going to be a post request for the context of this course, we're again going to pass in some kind of body, which means that we need to do the body equals json.loads request.data. Similarly, we kind of need to combine the two aspects of like creating a task as well as finding a specific task by ID, right? Because if we're updating a specific task, we also need to, browse through our entire database and find the first task that actually, matches the task that we want to change. So we do the same thing as we did previously. Task equals task.query.filter by ID equals task ID dot first. Then again, we still need to check whether this task exists or not, just to return an error if it doesn't. So if task is none, then return failure response, task not found. Again, since the failure response defaults to 404, we're good to go. But now if we're out of this if statement, that means the task was found. So we can just start updating things in that task, right? So task.description, which is the description kind of like field in that task object that we've retrieved, is body.get description, which is the description field in the request body that was entered in. And then remember that the .get function for a dictionary allows some kind of like default to also be passed through, right? Which means that if we cannot find a description that was given to us by the front end, then we would just default to whatever description had already existed there. So description, comma, task.description. And then task.done, same thing, body.get done, task.done. Okay, and here we just db.session.commit, since we haven't created anything new, so we can just kind of like save. And then we can return the success response. Any questions here?
Why don't we need like dot add here?
I think we don't need to dot add here because this task technically already like exists in our database. And since each like row in the database is associated with like that particular object, just like changing that is good enough. And we don't have to like do the process of re-adding it. Yeah. Okay, so let's go in here and check. So update a task by ID. In the body, let's say like, so the task was like getting better at Smash, right? So I don't know, lab backers, and then done. Let's just say it's true. Okay, so if we send this 8,000, we see that, you know, it gives us the task that we've changed, and let's get all tasks again. So originally it was get better at Smash. Now it's going to be lab backers. Any questions? Okay, if not, we'll go into the last thing for like the, I guess like main CRUD functionality of all of the tasks, which is just deleting a task. Again, remember from the previous demonstrations, when we delete a task, we still need to, again, browse through all the tasks to find the particular task that we want to delete. So when we need to do something like that, we do task equals task.query.filter by ID equals task ID dot first. I did forget to mention this before, but notice how in these endpoints, the task ID is like passed in as a parameter. So we can just like use that here essentially. Similarly, if this task doesn't exist, then we return the failure response. Here, instead of like doing like the add commands, you know, SQL Alchemy would probably also have like delete commands to help us delete entries in our database, which is exactly what we're going to call now as well. So db.session, this time .delete, delete this particular task. And then again, we need to save. So db.session.commit. In the previous kind of iterations of our to-do list app, we returned the task that we've deleted, you know, once we've like deleted it. So we'll be doing something similar here. Okay, any questions? Okay, if not, let's just delete it, change this to 8,000. And then the first one was labbing back errors. So we return the one that we actually want to delete. And if we get all tasks here, there should be nothing, which is exactly what it returns. Okay, does anyone have any questions overall on like the CRUD endpoints for tasks? Yeah. Yeah, so Serialize is essentially turning the Python like object that we've created in the code into a dictionary that can be turned into a JSON, right? Because we want to give back a JSON response to the front end, but we can't like make a JSON from an object directly. So we need to go through a middle path to turn it into a dictionary first, which is what Serialize does. Oh, can I use your charger? Okay. Okay, so next, let's go on to the subtask. So remember that subtasks are in a one-to-many relationship with a particular task, right? So this means, and we've kind of like modeled this already in our database, right? We have that the task ID has a foreign key of like task ID. So this relationship has already been modeled, so we can just go ahead and kind of program the create subtask endpoint. So for the create subtask endpoint, similarly, again, like our previous endpoints, we need to peruse through the entire database and look for the task that we're actually looking for, right? So again, that's going to be task equals task.query.filter by ID equals task ID, and the first one that we get. Again, if we need to check if the task is none, then we return the failure response of the task is not found. But here, we're also going to get some kind of like input from the front end, right? Because we're actually like going to be creating our subtask. So we need to do that part as well. So the body is JSON.loads request.data. So similarly as when we created a task and we instantiated a task object, here we also need to instantiate a subtask object. So we'll be doing that. A new subtask, it's called the like object creator subtask, the description. And this is going to be very similar to what you saw up here with like create task. So just body.get description done equals body.get done, and task ID equals task ID. So here, the task ID that's being passed into this field isn't from the request that the front end passes in, but instead from our URL, right? So this thing in the URL gets passed in as a parameter into this function, so we can just use it here. Then finally, we need to do the adding and the committing again. So we have db.session.add new subtask, and then db.session.commit. And then lastly, just like when we created a task, we return a success response and then serialize this particular subtask, which note also exists in the subclass, like class here in the database file. So return success response, new subtask dot serialize. Okay, anyone have any questions here? Okay, if not, we'll like create a subtask. So I need to create a new task too, because I deleted the only task I have. I don't know. Go to sleep. Okay. So to create a new subtask, I change this to 8,000, and there's only one in here right now. Just like brief reminder, just like take this like URL part and paste it in. Okay, so let's pass in. We don't need to travel to LA to go to sleep, but you can close your eyes first, I think. Yeah, so let's close our eyes. Okay, so here, when we like pass this in, we see that our subtask has been returned to us with an ID of 1, description of closing your eyes. I haven't done it yet. And also we have a field for the task ID that it references. Does anyone have any question here? So the reason why we didn't need to like specify anything further in our app.py file with regards to like the foreign key is because SQL Alchemy kind of like already takes care of that for us, right? Here in our DB file, where we have already specified that the foreign key is the task.id. Okay. Oh yeah.
So if you want to it together, is it gonna like the subtask is gonna be below the main task, or they are just two separate things?
Yeah, that's a great question. We're actually getting into that right now. So yeah, let's get all tasks again. So right now in our tasks, we just have like go to sleep, right? Which might not be super helpful for a front end if we have this concept of like subtasks as well, right? So we might want a way to, like you said, kind of display the subtasks along with the tasks. But so now the question is, right, how do we do that? So first we're gonna need to change kind of like the ways a task is going to be represented, right? So the task object in our DB file would need to have a field called subtasks, and we would need to be able to serialize that somehow in order to display it in our response. So that's the next thing that we're going to change. So let's go back into our database file and scroll back up to the task class that we've defined from last week. And we're going to add a couple of things. So the first thing that we're going to add, like I said a little bit earlier, is we need a field for subtasks so we can actually see, which subtasks are associated with our particular task. So subtasks equals, but this isn't just like a column in our, I guess, like if we were to represent this as a database, it's not going to be like a column anymore. So instead we define it as like a db.relationship. So SQL Alchemy knows that like the task and a subtask are in some kind of like relationship. So here, in previous, like, I guess like the previous demo, when we defined a foreign key, we referenced the table name task, which is like task with a lowercase t, right? But here we actually don't reference a table name. We actually reference like the Python class like object name. So it's task with like a capital T in this case, because the Python, I guess like convention is to name your classes with a capital like starting letter. Or sorry, it's not gonna be task, but subtask. So make sure to not name it the table name, but name it the name of the class. And then secondly, we want this field called cascade to be delete. So what does cascade equals delete mean? So when we have like a task, right? Let's say just like imagine like a to-do list app, and we have like a task and it has like a bunch of like subtasks. When we delete like a parent task, we probably want all our subtasks to disappear too, right? It wouldn't make sense to like keep the subtasks for a parent task that no longer exists. So that's essentially what this cascade equals delete field will do, such that if you delete something of like the parent, then all of its children would be deleted as well. Okay, any questions? And then for something like this, right, it also is another like demonstration as to why SQL Alchemy is like really useful. Because like in the past, if you were just using raw SQL, we didn't really like do anything about like if a subtask was deleted, then like, or sorry, if a parent task was deleted, then all our subtasks were deleted. You would have to probably manually go through that with more SQL commands. But here, SQL Alchemy has a field that would like do it for us. Okay. So yeah, and then we need to change this serialize function down here too. And here we'll be using our neat little I guess like Python syntactical trick. So s.serialize for s in self.subtasks. So now that a class task has a field called subtasks, we can now serialize everything that's in it. Okay, and let's give this a shot. So hypothetically, this should Okay, so cool. This has returned all of the, like our tasks go to sleep and the subtask associated with it, close your eyes. Any questions? All right. Okay. So yeah, that's basically it for like the one-to-many relationships in terms of like tasks and subtasks. And then the last thing that we're going to cover is a many-to-many relationship between tasks. And let's say we add something new into our to-do list app of a category. So we can think of a tasks and categories in a many-to-many relationship, right? Because one task can be in multiple categories and one category can have multiple tasks. So we will need to first define something new for categories. So let's go into our DB file and write a new class for a category. So remember, it's a model. I'll give it some documentation, and this is the category model. The table name here is going to be category. And then it'll have like pretty similar, let's just say it'll have pretty similar things to what exists in tasks. So like an ID and a description. So I'm just going to copy the code over from what we had originally in tasks or in like the task class. And then let's say like, we give it a color. So to like color code, like all of our categories. So db.column, this is going to be a string. And let's say it's not movable. Okay. So again, we need the initializer for this class. We take in like the keyword arguments parameter, and this initializes a category object. Similarly to what we did up here with both task and subtasks, we just need to get from the keyword arguments all of the fields that we need. Self.description equals quargs.get description, and then the empty string. And then self.color is quargs.get color. This is just defaults to empty if we can't find it. And then finally, we also need something to serialize this category object, right? So we'll be returning ID is self.id. Description is self.description. And then color is self.color. Okay, any questions so far? Okay. So lastly, we actually have to like set up like the many-to-many relationship between task and category, right? And if you remember, the way we do this between two I guess like tables is with an association table, right? To actually model in the association table, you have like two IDs that are like related with each other so that we can actually represent the many-to-many relationship. So we actually have to I guess like put in this particular like association table. Okay, so let's do that up here. So association table. This time it's not actually like an entity in our database. It's just like a table that helps connect these entities. So we just db.table. We call it association. And then we have db.column task ID. We define the columns, and one of them is going to be like a task ID, one of them is going to be a category ID, and it kind of references the ones in the original tables, right? So db.integer, db.foreign key. And here we need to actually reference the original table and the original column, which remember it was a lowercase task.id. And then we need db.column, category ID, db.integer, db.foreign key, category.id. Okay, so that basically sets up our association table. Okay, so sorry for running out of time a little bit at the end of yesterday's lecture, but we'll be completing our demo now. So we'll be hopping in right after we've defined the association table. So just a quick review, the association table essentially allows us to define our many-to-many relationship. We have two columns in here, one for the task ID and one for the category ID, so we can link task IDs with category IDs. So now that we have the association table, we actually have to go into each of our models, into each of our Python classes, and actually define the many-to-many relationship between task and category. If we think about it intuitively, right? Task currently has the fields ID, description, done, and subtasks. But if we want a visual way to also represent the categories along with a particular task, maybe for example, if you think of like the interface of an app, if you check your task, you might have a label there for the category that it's supposed to be in. We also need to define a field here for categories, right? Similarly, if we think about the interface of the app again, maybe if we're filtering by categories or searching by categories, it'd also be pretty handy to know which tasks are associated with a particular category. That kind of implies to us that maybe we also need an extra field here for tasks as well. So yeah, let's go and add those in. So here, let's define a field called categories. And just like above, the line of code about subtasks, this isn't a regular column, right? This column is going to define a relationship between tasks and categories. So we started off the same way. So db.relationship. And similarly as above, where we called subtask, which is the, with a capital S, which is the name of the class, we also want to call category with a capital C as the name of the task and not the name of the table. So note that there are two different things, right? The name of the class starts with a capital letter, whereas the name of the table starts with a lowercase letter. And technically you can name the table like whatever you want as well. But just the distinction here, at least in this demo, is that the class name starts with the capital letter, but the table names start with lowercase letters. Okay, next we want a field called secondary equals association table. What this does for us is that it defines this association table that we made up here as the sort of kind of like the backbone or the reference point for our many-to-many relationship. And we kind of want to store this many-to-many relationship in this association table. Then finally, we want a field called backpopulates. And we want to set this to tasks. So what does this do? Backpopulates as a field essentially allows us to make a bidirectional relationship. So essentially, if we make the relationship in one direction, the relationship is also made in the other direction. So as a more concrete example, if we say that X task is part of Y category, then our program basically also knows that Y category contains X task. So why is this useful for us, right? And what exactly does tasks, represent? So tasks is going to later be a field in category, right? As we kind of mentioned earlier, we want to put another attribute or field here for tasks to know which tasks are associated with this particular category. Since we defined the category class here, SQL Alchemy essentially knows to, look at the category class and populate the field called tasks. So essentially, if we add X task into Y category, that task X should show up in the tasks field of category Y. And similarly, after we've made that relationship, category Y should also show up in this categories field of the task X that we just made. So yeah, that being said, let's hop right into our category class and do the exact same thing. So here we have a field called tasks, like we mentioned above. And we want db.relationship again. Now we want to put in the class name of task, right? Still secondary should be the association table. And then finally, we want that backpopulates field again. This time, we want to set it to categories. So we can have that bidirectional relationship, and populating this tasks field means we can also populate the categories field. All right. So with that being done, there's probably one last thing that we need to do in this DB file. So like I was talking about a little bit earlier, it might be helpful to, visualize which categories a particular task belongs to when we serialize a task object, right? Because then it allows, the front end to take that output and just easily see, which categories our task belongs to. So we probably want to add something here for categories, which is going to be c.serialize or c in self.categories, because now we've added a field for categories. Similarly, maybe if we, serialize a category, we might want, to see which particular tasks are associated with it. Do remember to properly syntax or this dictionary object. In the demo, I might have not syntactically put comma here or something. So just make sure everything here is syntactically correct. But if we want to see, you know, what task this is associated with, we might also add a field here, tasks, which is t.serialize or t in tasks. But wait, there's clearly a problem here, right? Something might seem a little bit off. Here, when we return a task, we serialize all of the categories. But to serialize all of the categories, we then need to, you know, serialize the tasks too, which is problematic for us because it means that we have an infinitely recursive loop. But there's an easy way to solve this. The easiest way to solve this is just to, you know, serialize the category without all of the tasks when we want to serialize it in a task, right? So essentially what we can do is we can define another serialize function. Let's call this simple serialize. And this will serialize a category object without the tasks field. So here we just return an ID, which is self.id, description, self.description, color, self.color, and then that's it, right? We don't want the tasks to be serialized along with it. This way, when we want to serialize a task and serialize all the categories with it, we can just use the serialize function that doesn't have the problem with infinite recursion, right? That basically just use a serialize function that doesn't also serialize the tasks again. So let's just call c.simple serialize instead of c.serialize. And this should, you know, fix the problem. All right, so that's basically it for the DB file. Now finally, let's go into the app file and actually finish this assign category endpoint. So with this assign category endpoint, there's two things that we have to consider, right? First, we have to, you know, look for the task. And then secondly, we might have to look for the category, right? Because if the category that we want to assign to a task already exists, we should just, you know, use the one that is already existing in the database. But if the category doesn't exist, then we have to create a new category. But let's first start by looking for the task. So remember, we have to look for the database for the task that we want to, I guess, like utilize or like change in this instance. So task equals task.query.filter by, where the ID equals the task ID. And we want to take the first one that comes up. Then we want to check if the task is none. And if it is, we should return some kind of error, right? So return failure response, task not found. If the task is not none, then let's load in the JSON that's passed into us. So JSON.loads request.data. Let's get the description as well as the color. After that, let's create a new category object, right? So we want to create a new category object if it doesn't already exist. If it does already exist, then we should just assign that existing category to our particular task. We can label what our code does with an inline comment with a hashtag or like a pound sign or like a number sign. This is different from the triple quotes for docstrings. The docstrings tell you what a particular function does, whereas using just like a hashtag kind of just labels what particular lines of codes do. And this is also helpful for documentation purposes and just for code readability and other people, you know, kind of understanding your code. Let's label this. So create new category if it doesn't exist. Otherwise, assign existing. So that's what we're going to do below this comment that I put there. So first, let's search if the category even exists or not. Category equals category.query.filter by. Color equals color. Right. So we've passed in a color from the request, and let's see if that color or that color associated with the category already exist or not. And we want to get the first one that comes out. And if we can't find it, so category is none, then we'll make a new one, right? So the category is the constructor category, description equals description, and color equals color. So here, once we've either found the one that's already existing or created a new one, we can append it to the categories that this particular task would belong to, right? So task.categories.append category. Now let's save all of our work. So db.session.commit. And then let's return a success response where we serialize the task. Okay, so let's go ahead and test this in Postman. First, I want to just start up the app. So Python 3 app.py. Okay. Let's just start by going through the process of making like a new task. So yeah, let's say we just want to make the task of waking up. Send it. Okay. So here, you can already see the difference that we've made, right? So we have now a field for categories, and right now it's empty, which makes sense because we haven't assigned anything to it yet. Now let's assign a category to that task by ID. So that task had an ID of 3. Let's say this is like really, really hard, like crimson in color. So yeah, let's see what happens here. Okay, so as expected, we've asked it to serialize the task, right? If you remember in the code here, we put task.serialize. So it serializes the task for us, the task with ID 3, the description, the done. We haven't added any subtasks this particular task, and the category that it's really, really hard and of a crimson color. If we get all tasks now and look at this last task with ID 3, then we see that it shows up with the category. Okay, so hypothetically, if you before what we saw was like serializing the entire task when we added a category to it, right? So hypothetically, if we wanted to serialize the category and just see the new category that we made, instead of seeing the task that we made, another thing you could, depending on like what the API kind of specification wants, you could change this to category.serialize. So instead of serializing the task when we've like added a category to it, we actually just serialize the category itself. Just one quick thing we need to change here that I made a mistake earlier on. There's no field for tasks, so you have to change this to self.tasks because it's a field for this particular model here, or for this particular class. So if we just do category.serialize, and let's say we want to add this new category, extremely difficult, to our third task, which was waking up. Let's send this. Oh, did I save this? Oh, sorry, I didn't save the app.py file. But let's send this again. Cool. So now you see the output has changed, right? Instead of serializing the task with all of the categories associated with it, we serialize the category with all of the particular tasks associated with it. We don't run into a problem of infinite recursion here, even though we have the categories field here within the tasks, because we've called simple serialize when we've been asked to serialize the categories within a task. So we've been calling two different functions that don't like correlate with each other. So it works out. Yeah, so that's basically the end of this demonstration. As always, if you have any questions, feel free to ask on Ed, and we'll be happy to help. Yeah, so good luck with the assignment.